Hello everyone, my name is Audrey and I've been a BioScience program for 3 years. I'm happy to tell you about my project today. However, as you will see at the end, this isn't actually the talk that I thought I was going to give. First of all, I would like all of you to look at your hands. You might not realize, but there are millions of microorganisms living on your hands. If we look our hands under the microscope, you will actually might see something like this, or even something like this. Although you might be worried and feel gross about it, you should actually know that vast majority of these microorganisms are not harmful, but actually in fact are essential for your health. Now, you not only have microorganisms on your hands, but it's also on your surface areas. Sorry. Okay. You not only have microorganisms on the outside of your body, on your skin, you also have microorganisms inside your body in places such as your mouth, ear canal, or your intestines. All of these microorganisms that's living in you or on you all together are called your personal microbiome. Every person's microbiome is different from everyone else. In fact, your microbiome is unique to as your fingerprints. In addition, it is now well established that your microbiome is essential for your health. Also, it is important to know that it is not only humans who have microbiomes, but every surface areas also have microbiome. Each of our dining room tables has its own microbiome, as well as the salt shakers and the napkins. The door and the dial of your mailbox have its own microbiome, and every dorm room door handle has their own microbiome too. Now, for my project, I read a lot of scientific articles about microbiome. Among these, the most intriguing one was the hospital microbiome project. In this study, the scientists wanted to understand how microorganisms colonized and moved through a hospital environment. So they conducted their study in the brand new hospital at the University of Chicago. Starting 2 weeks before the new hospital was opened, the scientists collected microbial samples by swabbing different surfaces from all over the hospital. This included floors, sinks and faucets, railing on the patient's beds, and even the multiple surfaces in the nursing centers, such as countertops and keyboards. They also took samples from the hospital staffs and patients. They did this once a week for almost a year and ended up collecting about 10,000 samples. So here are some of their findings. Before the hospital was open, there had low diversity of microorganisms. But within just 24 hours, the hospital was populated with microbiomes that was similar to staff and patients. However, they also found that there was a directionality in this transfer of microbiomes from people to surfaces. For example, on the first day of the patient's stay in the hospital, the scientists found that the patient started taking on the microbiome of their room. But beginning on the second day of their stay, the room started to taking on the microbiome of the patient. So this was very intriguing for me. That got me thinking about the transfer of microbiomes at our school. So instead of the hospital microbiome project, I'm doing the dormitory microbiome project. Specifically, how does the microbiome of the dorm room change over the school year? I was very interested in seeing how the microbiomes of 2 roommates would change the microbiome of the dorm room. I first conducted a small pilot study several years ago, and I selected two types of surface areas, which one type was shared area that both roommates regularly touch, like this door handle. The other type was individual surfaces that only one of the roommates was likely to touch, like this dresser drawer handle. I collected DNA from these surfaces by swabbing them twice a week for total 2 weeks. Then with the help of BioScience program laboratory specialist Kevin Olson, I isolated and purified all of the DNA contained in each of these samples. After that, those labeled samples were sent to Genomics Center at the University of Minnesota, where the DNA was sequenced and matched to the organism it came from. For my pilot study, I compared the amounts of the different types of bacteria on different surfaces. As you can see, roommate 1 drawer handle is blue, roommate 2 drawer handle is yellow, and the door handle is red. Here are some different types of bacteria that were quantified, but I'm only going to focus on these 3. First, when you just look at the proteobacteria, you can see that amounts were about the same on the shared and the non-shared surfaces. However, when you look at the Firmicutes, here is amount found in the shared area, and here's the amount for the roommate 2 surface area, and this is for roommates 1. There is some indication that the amount of Firmicutes found on the shared surface is more similar to the amount that was found on roommates 2 surface. When you look at actinobacteria, as you see, it's somehow similar. It had somehow similar results. It appears again that the amount of the shared area is much more relatively similar to roommates 2 drawer handle than roommates 1 drawer handle. It almost looked to me like roommates 2 microbiome took over the shared surface instead of roommate 1. Now, this was just a pilot study with some intriguing results. I needed to do a more robust study in order to see if one roommate's microbiome could actually take over another's. So here's what I did. First of all, I increased the number of non-shared surfaces from which I collected DNA, which are toothbrush handle and the desk lamp. And second, because the dorm room door handle would probably be touched by many other people than the 2 roommates, I decided to only collect samples from the light switch that was in our closet, so it was very unlikely that other individual would touch this surface and would only contain microbiome DNA of the 2 roommates. I also arrived campus earlier than the other students and thoroughly cleaned all the surface areas in the room. I wanted to make sure that only DNA I would be collecting would be from the 2 roommates. The another change was that I collect samples more often, and I collected samples over a longer period of time, about 7 weeks. So with a much more robust protocol in place, Mr. Olson and I isolated the DNA from all of the samples and again sent them to University of Minnesota Genomics Center. And here are the results. Nothing. Sadly, shortly after the Genomics Center received my samples, they gave me the unfortunate news that none of my samples contained enough DNA in order to be sequenced or identified. So now, instead of talking about conclusions of my study, I will be talking about how this happened. I determined that there were 3 potential reasons for this. First, I collected samples by rubbing the surfaces with dry swab. However, in the hospital microbiome project, they moisten the swab before they collect the samples. This probably resulted in the collection of much more microbial material. Another consideration is how often the surface were touched. In the hospital setting, Surfaces are touched all the time by many different people. However, in my project, I use surfaces such as straw handle, the light switch, and the toothbrush handles that were not touched very often and thus did not accumulate much microbial contamination. However, the most important thing may have been what's called pre-project sanitation. And in my project, I did not sanitize any surfaces at the beginning of the study, for my pilot study. But however, in my current study, I sanitized surfaces at the beginning of the year before I started collecting samples. So this probably also decreased the amount of microbial material that could be collected right from the beginning. So even though I was not able to get an actual result from my 3-year-long project, now I deeply understand why science moves so slowly. However, on the bright side, I'm pretty sure that my project is all ready to be started for my PG year. Just kidding. Thank you.